The integral from a to a from f of x dx, we already discovered that is 0. Number 2, the integral from a to b from f of x plus g of x dx. The same with the sum, the same with the limit, everything the same property really, is the integral from a to b from f of x dx plus the integral from a to b from g of x dx. Obviously the same thing. If this is minus of course. Property number 3. The integral from a to c from f of x dx is the same with the integral from a to b from f of x dx plus the integral from b to c from f of x dx. What is all this? Here it is. Here's the function. Here's a, b, and c. I want to find the area, the integral, the definite integral from a to c from f of x dx, and I can split it into 2 pieces. I can determine this area from a to b from f of x dx, and then add this area from b to c from f of x dx. 4. Stop me if you have questions. If a function is greater than or equal to 0, its integral from a to b, of course on the interval a comma b, from f of x dx will be a positive number. 5. Odd function on a symmetric interval. So I want to find the integral from negative a to a. That's what the meaning of symmetric interval. Negative 2 to 2, negative 5 to 5, from f of x dx, also knowing that the function is odd. And before you tell me what it is, let us picture this. So here is an odd function. And here's an interval between negative a and a. What do you think this equals to?
0.
Awesome. So this is always the case. These 2 pieces are equal, but this is a negative area and this is a positive area. Since they are equal, one is negative, one is positive, the answer is 0. Thank you, Mark.
If it's an even function, is it just double?
That's my next, exactly. Double from 0 to a. Exactly, that's my next step. Property 6, even function on a symmetric interval. The integral from negative a to a from f of x dx. And this is the picture before you say anything. This is an even function. Negative a to a, and this is the area in question. Why would I want to know that this is even, and every time I have an interval that is symmetric, I always look and see what type of function this is, always. If I have negative 5 to 10, it doesn't matter if the function is odd or even. But if it's negative 5 to 5, I will always look at the function. It must be continuous, and if it's odd or even, then I know what to do. In this case, is indeed twice the integral from 0 to a from f of x dx. And you can say, what's the big deal? You haven't accomplished much. I have a lot. because every time the lower limit is 0, the calculations are always easier to perform. Always. So I will gladly, when I see a symmetric interval and an even function, I will gladly change it into this immediately. 7. The integral from a to b from f of x dx is identical with the opposite of the integral from b to a from f of x dx. 8. If a function is less than or equal to another function on an interval a comma b, so here's function, this is the interval a comma b, so here's the function f of x, and here's function g of x. What do you think will happen? What will be the relationship between the integral from a to b of f of x and the integral from a to b from g of x dx? Just that. Because this area will definitely be smaller than this area. So if a function is lower or equal to another function on an interval, then the area under the f of x will definitely be smaller than the area under g of x. Okay, number 9. Let's take a look at the following scenario. This is a line y equals uppercase m. This is another line y equals lowercase m. This is the interval a comma b, and we see that on the interval a comma b I would write that lowercase m is less than or equal to f of x on this interval. I don't care what happens outside, and is less than or equal to uppercase m. What do you think I'm going to do to all 3 sides? Exactly what I did to those 2 sides. What do you think?
Apply the integral from a to b.
Exactly. So obviously the area, then the area from a to b from m dx, please do not forget the integral goes with dx at all times. Less than or equal to the integral from a to b from f of x dx, and less than or equal to the integral from a to b from uppercase m dx. Now, these 2 I can determine. What function prime is m? From a to b. What function prime is uppercase m? Good. From a to b. I plug in b, I plug in a. Enough properties. I would like to apply a few of them. So let's take a look. I'm going to share my screen. So now we are ready for this. Choose any problem. Which one?
57.
Very good. Yeah, I wanted to do one of the 53 and 54. I will not forget. I just wrote 57 on the side. We'll do 57 in a minute. But I would like to apply one of the properties. Which one? Okay, 54. So the integral from negative 2 to 2 from f of x dx, where f of x is 2 for negative 2, 0, and 4 minus x squared for 0 to 2. Perfect. Thank you. Good. So now we notice this is exactly one of the properties that we just discussed. The integral from a to c from a particular function, and then the integral from a to b from a particular function, and b to c from a different one. Although it's the same function, f of x. But 2 is defined only between negative 2 and 0, and 4 minus x squared is defined only between 0 and 2. So then the integral from negative 2 to 2 from f of x dx will be, can anyone dictate? Very good. From negative 2 to
0.
very good. And then from 0 to 2 from 4 minus x squared dx. Exactly. Because I cannot, we have two different functions, and each function has to be integrated on its interval. So 2 dx from negative 2 to 0, and from 4 minus x squared from 0 to 2. And that will give us the entire area under the graph between negative 2 and 2. So then, 2x from negative 2 to 0, and 4x minus x cubed over 3 from 0 to 2. So, I'm trying to be funny. Would you prefer this for linear, quadratic, and cubic, or the fundamental theorem of calculus?
Definitely the fundamental.
Right, of course. But we needed to understand where is it coming from. So I plug in 0, leave the constant outside, 0, minus, when I plug in 2, so that will be positive 2. Plus 4, when I plug in 2, I get 8 minus 8 over 3. There is no need to plug in 0 because this is 0 and this is 0. So then I have 4 plus 8 minus 8 thirds, or 12 minus 8 thirds, or 36 minus 8 divided by 3, or 28 over 3. So this is the area under the graph of this function between negative 2 and 2. Yes, I see a symmetric interval, but I don't have this. I mean, it's two different branches. I cannot even think of odd or even. I would have loved that. So every time I'm asked to find a definite integral, first I make sure that the function is continuous on this interval. Secondly, if the interval is symmetric, I'll check whether it's odd or even. Okay. We also selected 57, so let's take a look. 57. So we have y equals 4 minus x squared and y equals 0. Perfect. This is basically a problem that really fits in Calc 2, but that's okay. It's good here too. Okay, so first of all I have to graph. I'm asked to find the area, the enclosed area. Okay, so let's see what this is. So first of all I graph y equals 0, which is no problem. And then I will graph 4 minus x squared using transformations. I know that this is x squared. I know that this is negative x squared. And I know now that the graph is pushed up 4 units. And I also know that it will cross at -2 and 2. So here's the graph. So this is the graph of y equals 4 minus x squared. So the area enclosed between this graph and this graph is obviously this. So the area between graphs, first of all, I need to identify the points of intersection. This, I know it's negative x equals -2 and x equals 2. So this is the area between -2 and 2 from the upper function, which is 4 minus x squared, minus the lower function. Yeah, it's not a big deal because it's just 0. The function is continuous. A function has a symmetric interval. Is it odd or even or none of the above? If you say odd,
Looks like it's even.
exactly. So this is twice the integral from 0 to 2 from 4 minus x squared dx. How do I know? In the function, I plug in -x and nothing happens. It's still the same function. That's why I know it's even. And it's so much easier to calculate with 0 here than with -2 here. Not a big deal, is not a big difference for this function. So 2, 4x minus x to the third over 3 from 0 to 2. And I only need to plug in 2. Because when I plug in 0, everything is 0. So 2, 8 minus 8/3. And I will calculate. So 24 minus 8 divided by 3 with 2 in front. So 2, and this is 16, 32 divided by 3. And this is the area enclosed